Hello everyone, welcome to the lesson 4 in the module 4. This lesson is about transformation of linear functions. We have studied about linear graphs, anything that has to do with a straight line. Say this is the equation for y equals x, a slanted line at 45 degree over here. So this is the linear function, example of a linear function. Now transformation means that there can be equations, say y equals x plus 3, y equals x plus 3. Now how can we get this from the parent function? This is called a parent function, we'll come to it in a while. So how do we get it from this? Or if we have, say now it's plus 3, so all you need to do is 1 2 3, and that's it. Now whereas y is equal to 2x minus 3, how would this work? Now these are all transformations of the parent function, and we will study all this in this particular lesson. Now in this lesson we will learn to apply translations to linear functions, apply dilations to linear functions, and to apply reflections to linear functions. We will study all these three objectives one by one. You will understand better when we come to those topics. And the keywords are family of graphs, parent function, identity function, transformation, translation, dilation, and reflection. So we will come through this one by one. Now we will start with the transformation of linear functions. Over here there are few things that has been told. A family of graphs. See now, there can be different types of graphs. Say, y is equal to 3x is something, y is equal to x minus 3, y is equal to minus 2x. You can see all these are different equations or functions, right? All these have something in common. This is that x. Okay, so all these you can see as at least one thing in common, that is x is common. So they are all family of a graph, and the parent function is the simplest of all. That is, see, the numbers will change but this x remains here. So this is the parent function here. Okay, so now the transformation, what happens is, how do we transform this function from the parent function? Over here there is something called dilation. We will see in it in a while. Now this one is very easy, x minus 3. Imagine this parent function is graphed. X, this is y equals x. Minus 3 would be horizontal translation down 3 units. That is the answer. So this is called transformation, and this moving from one point to another is called translation. Those are the things that discussed. But now we will understand better about vertical translations. Here we can use Desmos to understand better. I'll quickly go to Desmos over here. Just focus on the first graph over here. This one, this is the parent function graph. Now we are dealing with vertical translation. Let me see this graph. You can see the blue one, right? Now if I add anything to x, y is equal to x is the parent function. If I add anything to it, so as I increase it goes up. Can you see the y-axis? See, from it was at 0, right? So initially it was at 0 over here. You can see that's the parent function at red. Now this is moving upwards. Why? Because I'm adding some number. It's so easy. You just need to translate this parent function to whichever graph they tell, whichever point they tell. If they ask you x plus 2.5, all you need to do is translate this to 2.5. That would be the graph. You can see this is, instead of 0, it's at 2.5. Same thing with negative direction, it goes down. As you can see, it goes down or up. If you want minus, say minus 3, it's over here. It's moving down now. This is it about vertical translation. It's one of the easiest. Now let's go back over here. So what can you understand over here? You can go through this in your own time. It's very simple and basic. Now here they have told to describe the translation in g of x, that is equal to y minus 2, and relate it to the parent function. Now, you know graphing already. We have studied that previous lessons. So if you still are confused on graphing, please go back to the previous lessons, be thorough with that, and then continue this video. We will see how to graph it in a in a simple way. That is the table of methods. But guys, if you really want to directly do it, you can, because you know what is y equals x. See, this is the parent function, f of x equals x, or y equals x. So the function would be something like this. Okay, and now it's minus 2, so this is minus 1, minus 2. You should just translate this down by 2 units. That's it. That would be the answer. Okay, but anyways, if you're doing it from scratch, then make the table x. You need to assume these values. It's up to you. If you have 2 points, it's more than enough, but you should have minimum 2 points or more. 3 is fine, no problem at all. So values before 0 and after 0, that is -2, 0 and 1. Now what do you do here? All you need to do is, see, this is the parent function, okay, f of x. Now what is the given function over here? X minus 2. So basically g of x, this is g of x, parent function minus 2, or you can just substitute these x values here. The parent function here is y, sorry, it's f of x. Y or f of x is the same, is equal to x. So whatever x values we assume will be the same for f of x. That's the parent function. Now here, the next column, that is g of x, all you need to do is put this x instead of, put this value of x, that is minus 2 instead of x over here. So it'll be minus 2, it'll be minus 4. Put 0 next, 0 minus 2 is minus 2, and lastly 1 minus 2 is minus 1. So these will be the answers. And what about the last column? We just write it in terms of pairs. That is x and y, minus 2, minus 4, 0, minus 2, and so on. Now here, f of x, if you have to graph f of x, you need to graph these 2 columns, right? When it's minus 2, it'll be y will be minus 2, and minus 2. If it's 0, it is 0, 1, 1. If it's any point, if x is say 4, y will be 4. So that is how we get these points. Parent function is very easy. Just draw a straight line. Then this is the transform graph. You can take this coordinate points and graph it, and you will get this line. But now look at this. This was 0, 0. Now it has moved down. X value will remain same, 0, but y value is moved on by minus 2. So what you can understand is, whenever the question is x minus like this, there is no brackets, right? It's always to do with the y axis. If it's x minus 3, x plus 5, it's always to do with the y axis. Okay, y axis. Whereas if it was x minus 3, the whole bracket. Now you might be thinking, yes, this is x minus 3 without bracket and it's the same thing. Yes, but generally whenever we have brackets, it is something to do with x. That would be a x-axis. Okay, now where the difference would come is, see, 2x minus 3. Now you can see this 2 has to do only with x. 2 has to do only with x. Or if you have 2x minus 1 minus 3, this is with x. This is the extra function. So if you graph this, and then you should just go down by 3 units. This part, minus 3 or plus 3, outside the x, whatever is denoting like this, is moving it up and down. Now here then we have, now one thing to remember is, see, whenever we write this, it is written like this, k. The standard form for vertical translation is given by x plus k. So what happens is, over here you can write, after the graph, here what is the k value? It's minus 2. So the parent function minus 2 is the answer. So all you need to write over here is, the k affects the output of what values? It's not the x, it's the y axis, right? So the y values, that is very, very important. Okay, now here You're writing magnitude negative 2y because it's moved down by distance. So we just use magnitude symbol because it's distance. That's how we write it. Now here these are all simple, but if you understand the graphing, that is the most important thing. It's always, sorry, this part has always to do with the y-axis, and this will always, yeah, that's the main thing, okay, about y values. Now it's moving down by 2 units. What about the other check problem? Try this by yourselves. Here they are not asking you to graph and stuff. I mean, they're just asking how is the relationship. You can see it's -1, so it's moving down by 1 unit. So the graph of x -1 is the translation of graph the parent function 1 unit down. That's it. This is the, sorry, this is the parent function, right? It goes from 0 to 0. -1, if it's over here, just draw a line. Same line, it's translated down by 1 units. That's the answer. Now we will look into horizontal translations. Here, horizontal translation has to do with x value. Now look carefully. This standard form is given as minus, okay? Why? Because now in this function, see, relate is minus. I'll then change it to plus and make you understand easily. Now h minus. So what happens is plus. Okay, 1 second. I have not used this. Let me remove the horizontal one. Now it's the horizontal. Now, if you think carefully, these both are same. Yes, absolutely. If you see it as, what's happened? Okay, if you see over here, it goes down or up. Yes, it moves in the y-axis as well, but now I want to focus everything with the x-axis. Look, only this x value, this side and this side. Now I'm just going to move it once. Left side will be negative, right side will be positive, right? But look at the function given, it's minus, okay? The standard form is generally minus, but if you put this as plus, then it's easy to understand when you graph it in your exam and stuff. I'll make it plus for now. Always remember, when you have, say, function x plus 3, don't think this is plus 3. It goes to the left side. Why? Because x equals -3. Take it to the other side. If this is equal to 0, take it to the other side. X equals -3, so this will be the point. Let us go over here. Plus 3, sorry. Can you see? It's at -3. So always remember, whatever the function is, with x, not added or subtracted, it's along x, okay, inside the brackets. If it's -2, now you need to change the sign. Think in your mind, -2 means to the right, +2, okay? So -2 over here will give you +2. So we will look into the problems now. Always remember, here it's +5, right? So this is the parent function. All you need to know is where is -5. Here the graph will be translated. See, the final answer of the graph is left side by -5. The way we do is the same thing, just like how we did a while ago. -2, 0, 1. This is the function x plus 5. So just put the x values here. It'll be -2 plus 5, that is 3. Then it's 0 plus 5, that's 5. And lastly 1 plus 5, it's 6. So these are the answers. And then you write them in ordered pairs and you can plot them. But the easiest method is just know the parent function always passes from 0, 0. And this will be 5 units to the left. 1, 2, 3, 4, 5. Yes, 5 units to the left. Okay. Now, here now, whenever you're writing how much distance it's going, don't write +5. Just remember it's to do with -5. Why? Because the standard form is really -h, so it is written like this. No need to do all that. Just remember, if it's plus, you're just write minus. Okay, it'll be going to the left. +5 means to the left, minus would mean to the right. And there's one more important thing which you must remember. Always when it's in bracket, it's relating to x-axis. It deals this value over here, 5 deals with x values. It affects the x values. You will see this problem here. Looking at it, you can understand if this is the parent function, +2 means left side, minus 12. It will be something like this. Okay. Now here they have not asked to graph. Just to understand the graph, x plus 12 is a translation of the graph of the parent function. 12 units where, left or right? If it was vertical, if it was y-axis, plus was up above, minus was down. But here it's different. When we deal with the x-axis, the horizontal axis, if it's plus, it's the left side. This will be 12 units left. Okay, that's the answer. Now, what if there are multiple translations like this? So there are various ways to solve these. Now, all the problems, there are different tactics, different methods. You can choose any of them. Now, for example, over here, describe the translation g of x equals x minus 6 plus 3, right? One thing can be done. You can remove the brackets and solve this. X minus 6 plus 3 would be x minus 3, and then it's x minus 3. I mean, without the brackets, sorry, don't put the brackets, you remove the brackets, so it'll be minus 3 somewhere over here. That's possible. Okay, or you can do both. Let me just show you the graph over here. 1 second, look at this graph. Here you can tell x minus 3. What happens when it's x minus 3? Let's consider one point here, this one. It'll go right side by 6 units, isn't it? If we have plus 3, minus 3 inside, it'll be going to the right by 3 units. So it's 1, 2. Now over here, the units, I believe 2 units are 1. No, anyways, let's do it. Sorry. 1, 2, 3, 4, 5, 6 here. Okay, this is the point. And now there is plus 3 outside the brackets. That means it moves upwards by 3 units. That is the y-axis. So again, 1, 2, 3. So this is the point. This point is moved up over here. So there will be one point over here. Same way, let's transform another point. Let me take this point over here. You can see 1, 2, 3, 4, 5, 6, and 1, 2, 3. This is on one more point. And when we draw, we will get it. Or the simpler version is x minus 6 plus 3. Solve the numbers. X minus 3. Now let's see. X minus 3, you can do 1, 2, 3. That's it. Or if you're considering the brackets, it'll be right side horizontal. 1, 2, 3. Minus would be right. So it's up to you. Okay. But now over here, we need to understand the 6 units over here is a right side. Why? Because inside the bracket means right, and this outside the bracket is always plus, means up, minus is down. That's the vertical axis. Okay, 6 units right, 3 units up, and whatever is inside the bracket is denoted as h, and outside the bracket is k. So that's now we have a real world problem here. All these problems are very straightforward. Let's read this. Tickets. A website sells tickets to concerts and sporting events. The total price of tickets to a certain game can be modeled by the function of time, f of t, equals 12t. Sorry, not time, t, okay? F of t equals 12t, where t represents the number of tickets purchased. Okay, the website then charges a standard fee of $4 per order. The total price of an order can be modeled by this over here. The total price of the order, g of t plus t. Now, if you understand these, let's see. If you're buying one ticket, if you're buying one ticket, the function f of 1 means it's $12. Okay, let's consider dirhams, 12 dirhams. Now, if you want to buy 5 tickets at once, f of 5, okay, you will be 12 into 5, that is $60, 60 dirhams. Now, there is a order fee, that is the processing fee. It doesn't matter how many tickets you buy, there is a one-time charge of 4 dirhams. Now, imagine you bought one ticket, it's 12 dirhams, right? If you just bought one ticket, then there is another fee that is plus 4, that's a constant, it will be 16 dirhams. But here you bought 5 tickets, doesn't matter, it's 60, but only plus 4, that will be 64. So this that order rate is not for number of tickets, it's number of purchases. So you go and buy 10 tickets at a time. You want to just pay 4 dirhams extra, not for each ticket, just one time. But if you buy 10 tickets separately, 10, then it would be very expensive. See, if you buy one ticket, it's 16. So 10 would be 160 dirhams, isn't it? But if you buy the 10 tickets together, okay, at once, it would be 120 plus 4, 124 dirhams. So you can see this processing fee can be avoided if you buy many tickets. Now then, they have asked us to see what's the translation between the two functions. Okay, um, we can see over here, complete the steps. See, what is the parent function is with the derivative x, but first, what is added to it separately? That 4 is being added, so that is up and down. You can see in the question this plus 4, right? It is added separately. That means that will shift the graph 4 units up. So that's it. Now, if this is the original graph, this is the 12t graph, okay, function graph. All you need to do is shift this by 4 units. You can see from here 0, 1, 2, 3, 4. This is the point. It just shifts by 4 units. Any point you consider, it's being the new graph, the g of t graph, is being shifted by 4 units. That's it. Basically, you have to graph both of them. Now, if you're wondering how to graph 12t, you can make a table and graph, or it's very simple. The slope is 12. So, for 1 unit over here, when x is 1, y value would be 12. It's somewhere up, very up, right? It would be 12. We will see that in a while, okay? In the next type of problem, we will solve those problems. So similarly, we have one more check problem. Please pause the video and try it by yourself over here. Let me read it out. Jerome is buying paint for a mural. The total cost of paint can be modeled by the function f of p equals 6.99p. He has a coupon for $5.95 off of his purchase at the art supply store. So the final cost of his purchase can be modeled by g of p equals this equation given over here. Describe the translation. See, this is the initial function, the final function. All you need to do is find the difference. Yeah, mural means a painting which is on a wall, generally like graffiti, but it's not exactly a graffiti. Graffiti is something, some of the walls in films or something you might have seen, there'll be a painting and stuff. So that's something. It's not on a painting, like you can't hang it on a wall, it's the entire wall itself. Now here, you can see, okay, they have just told how to do this. See over here, this function doesn't have anything added to it. This is the parent function here. Now minus 5.95. So what happens? If this is the first graph over here, it will be I slope. The second function will be shifted down by negative 5.95 units. That's it. So 5.95 units down. Now then we will go to dilations of linear functions. Dilation, you can see over here, dilation means it either stretches or compresses. Now, what is stretching? Stretching is, say for example, you want to stretch this line. Okay, you're stretching this upwards. Pull these from both the ends. What happens? It becomes longer and it would be something like this. Initially original position was over here, but final would be more upper. So it would be more steeper. Whereas if you compress, imagine you're pushing this line inside from both your hands. Press it in. Okay, press it in. So what happens is this becomes a bit more thicker and it tends to go a bit like this. Okay, like you can see over here, this is compression. So what's happening here? You must always remember, whenever you have the first value greater than 1, like say 2x, 3x, 5x, it is always a greater, it's a stretched vertically, it's stretched vertically, okay? When the values are less than that, say for example, it is half x or 0.25x, then here it is being compressed. Okay, it will be less, the slope will be less. How do you understand otherwise? Now, one important thing is, since we are talking with vertical dilation, it's always 2 multiplied by x. It's not like this 2x bracket. No, brackets are not there, it's separate. Always remember, when it's more than 1, greater than 1, sorry, x is greater than 1, the slope becomes more, right? It's 1.5 to 2.5, it's more than 1. So this is the slope of 1, right? 45 degrees, it's more than that. It always goes up, it's vertically stretched. Whereas when it's less than 1, it will always be compressed. So this is one important thing you must remember. And we can see over here, sorry, where is it? Over here, the Desmos. See here, this part. When you are multiplying this a to x, but it's more than 1, you can see it goes higher and higher. Whereas when you're reducing it less than 1, you can see it's going down and down. Okay, so if you're going negative number, we will see that in a while. That's a separate case altogether. But understand, when it's less than 1, it is less than, it's vertically compressed, and bigger than 1, it's vertically stretched. Now we'll get back over here and see some problems. Okay, about the horizontal dilation, sorry, it's a similar thing, but when a value is bigger and you're multiplying inside, see the brackets are there, that's the only difference over here. We'll directly see it in Desmos over here. Okay, I have over here this part. If I have more than 1, again it will be horizontal. Now here it's horizontally compressed. Now this is one thing you might be thinking, why they are just using different terms. See, I was talking just now about vertical. Now we are dealing with horizontal. Horizontally, when it goes up, it's compressed. You can see horizontal is like this, right? Like this, flat line, horizontal. Now you can see this is more longer, and as it goes up, it becomes compressed. As it is going up vertically, yes, it is being stretched, but horizontally, what, it's becoming small. Whereas over here, it is being stretched, it's becoming bigger horizontally. So if you're dealing with horizontal, it's always the x-axis. Vertical is the y-axis, so it can't be the same. Now here, when it is vertically stretched, it is the opposite of horizontal. What? Horizontally compressed. Okay, you can see horizontal point of view, it's becoming small, whereas this is becoming bigger to it. So this is the concept. Now you can see over here in the Desmos as well, it's the same thing. There's no much difference. It goes up, but horizontally it becomes smaller, and vertically it's now it's vertical compression but horizontally stretched. I hope this is clear. Just try to see these graphs, see the Desmos, try to understand, contemplate it, and play around the graphs. You can see, you can just see what I have written over here. You can just type it by yourself in Desmos, and you can move around and understand it well. So that's the thing. And over here we will see a problem, you'll understand better. Now they are talking about vertical dilation. See, the bracket is only for x and something is being multiplied. When the constant term 2 or 3 or 4 is not inside the bracket, then we are dealing with vertical. So it's vertical dilation. Now you can see this value is 2, it's bigger than 1, it's greater than 1, so it goes higher. So it's vertically stretched. That would be the answer. You can graph it, and over here, see, this is the parent function, it's going upwards. Okay, how much upwards? That there are various ways to do it. Now if you see this number 2, so x equals 1, y will be 2. Okay, or if you take any point. Now don't think this is just always 2. No, it's not like that. This is a bit misleading. What you can do is, see, when x is 1, y will be 2. Okay, from 0. So here, if x is 2, y will be 4. That's how it works. Okay, and now over here you can see it's stretched vertically or vertically stretched. And what is the factor of stretch? It's 2. That's the thing. Okay, what is the steeper? Steeper means it becomes more and more bigger, say like the steep, okay, sharp, you can say. Whenever it's vertically stretched, it is always steeper. Now here again, it's the same thing, 6. Now over here, the graph 6x is vertically stretched, vertical stretch of the graph of the parent function, and it is what the graph, the slope. Now we can see the slope of parent function is this is equal to 1, right? This 6 will be somewhere over here. It is bigger than, the slope is more steep, right? It's more bigger. So that's why we call steeper. Okay, it's more. That's how we do it. And then the sixth one is about horizontal dilation, sorry, horizontal. Horizontal is with the x-axis, and you can see the brackets are inside, the term is inside the brackets. Now this is to do with x. Now here, when we graph it, you will get, say now if I just graph this, the parent function, this will be down. So it's going close towards the horizontal axis. So it's horizontally stretched. You can see this one is horizontally stretched. You can see over here, initially it was over here, but it's going more and more horizontally. Now, how would you solve this? 4, 1 by 4th. How would you know? This function for one x-axis, this is dy by dx, right? Always. So for one y value, 1, 2, 3, 4 x values. Okay, that's it. If it was 4x, then what happens? It's dy by dx. So for 1, it's divided by 1. For one x value, 4 y's. Okay, that's what we did previously. Now here we must remember to tell stretched horizontally, not vertically. Vertically it's compressed, but this is stretched horizontally, and the factor is 1/4. Okay, and now is it steeper? Is the slope? See, the slope over here is higher than this line, so it's less steep. That is, the slope is lesser. Okay, less steeper. And we come now, that is about, just now was about dilations. Now we will see reflections. What is reflection? If I have like this, the reflection would be like this. If I have something like this, the reflection. Okay. Now then, we will see what reflections are. Reflection is basically when you multiply -1. Now, how it is multiplied makes a difference. Really, you can do it directly, but the concept is when you multiply negative sign as a whole. See, when multiplied -1 before or after the function, okay, that is to do with the y-axis. Now, reflection along. Wait, let's see. This is important, these sentences. The graph negative f of x is reflection of f of x equals x across the x-axis. Okay, I'll just make it. Now, how to remember this is when you're multiplying minus and x is separate. Okay, not inside the bracket. You come with the first case. Now, what is this case? See, you can see this is inside the bracket, this is outside the bracket. Here, it's just that if I have, say, this point is 1, 1, the other point, x value will remain the same, only the y changes its sign to negative. Is that okay? Only the y changes. That's what happens. Now, here, you're reflecting along the x-axis. But you don't get confused. Yes, along the x-axis, but the y values only change. Why? Because it's along the y-axis, and this y coordinates become positive and negative. Whereas here, it's the other way around. It's along the x-axis, but the x coordinates, if this is 1, 1, the x coordinates changes -1, 1. That would happen. So over here in this case it would be bracket. Okay, we will see a problem you'll understand better. Now it's -half x. Now negative is outside, so all you're doing is when you graph over here, what they are saying, it's along x-axis. So now imagine this point 1, 2, 3, 4, 4, right? Oh, now this is gonna change based on the slope. Wait, first of all, you must understand it's along this axis. So The x coordinates won't change. It's 4. This also will have 4. Only the y coordinates, this is plus, this will become minus. But it's not 4 and 4. Why? Because there is half. It will change over here. That is the main concept. Okay. And here you should understand minus 1 is multiplied separately. So like this. That is outside. So we deal with the x-axis. And then over here, if you see what is happening, vertically it's compressed. Why it's vertically compressed? Because of this half. What does half do? Half is multiplied outside x. It is vertical compression. Just that negative sign makes it makes a reflection as well. Okay. And since this is again important, the negative sign, is it grouped inside x? No, it's outside. So the reflection is along x-axis. We had seen over here the first case. This is the first case. If it is grouped outside of x, see it's outside, then it is along x-axis. If it was grouped inside with x, it is along y-axis. So that is the concept. That's it. Very simple. If you have understood the first few concepts, then graphing any of these is very, very straightforward. Now, how can you tell whether multiplying -1 by the parent function will result in a reflection across x-axis? Now let's see the options. If the constant is not grouped, yes, if it's not grouped with x, the result will be a reflection along x-axis. This is correct. Wait, let's just go through the options. If the constant is grouped with x, then it's a reflection along y. See now, if it is grouped in the sense there's bracket, it's going to be along the y-axis. That was the second case. Okay. If the constant is greater than 0, the reflection, no, this is wrong. It's about the sign, right? So if the constant is not grouped with x, the result will be the reflection along x-axis. That means it's like this, minus f of x. Okay. These two cases, what happens? If you have a graph like this, it will be along this axis, along x-axis, it will come down. Okay. So this will be 1, 1. Over here it would be 1, minus 1. Only the y values changes. So answer is A. And now let's see along the, if it's grouped inside. See now it's grouped inside. What happens over here? Same like the previous one. Only thing is we are dealing with these 2 points now, like this. Okay. So it is along over here y-axis. It's horizontal. Now, how do you tell it's horizontally compressed? With this, it's 3, right? So 3 means it will be compressed. Now, first important thing. Since it's inside the bracket, it has to do with the horizontal section. Okay, because it's inside the bracket. If it was outside, then it has to do with the vertical axis. But since it's inside, it's always horizontal. It's not vertical now. And horizontal, as the slope is bigger, see it's more steeper, what happens? It goes away from the horizontal axis. This is more near, this is more far. So basically you have to tell this is horizontally compressed. That's the first thing. And here you're dealing with the y-axis. The reflection is along y-axis. Okay. And over here the same thing what we just now did. Let's see, the graph is minus 10x and the parent function is compressed horizontally. Yes, because we are dealing with the horizontal axis inside bracket. And now since it's minus 10, it will be something like this to the parent function. It is compressed horizontally, whereas it was vertically stretched, horizontally compressed. And over here we are dealing with y-axis. Whenever it's inside bracket, it's always with the y-axis. When it's outside the bracket, it's along x-axis. So that's the answer, and that's the end of this lesson. I hope you found it helpful. It's a bit lengthy lesson. It's just graphing. If you have understood the first few concepts, then it's very straightforward. So please be careful with the translations. The first one, x plus 2, then x minus 2 with bracket, and these 2x and 3x. Then if you know these, minus x means only the opposite side. So if it's like this, it just changes its sign. Okay, it just becomes the other side. So this can be done last. So do these transformations first, understand them thoroughly, use Desmos, you can understand better, and then you can easily add up all and easily transform the graphs. If you have any doubts, please do post them in the comments. I will try to get back to you as soon as possible. And until the next video, bye bye and take care.